I want you to notice also on this graph that we could not synthetic divide it, so we could not rewrite it as a parent function. So when the degree of the numerator is the same as the denominator, you also have this option of no parent function and just finding your asymptotes by your a over b for your y asymptote, and set your denominator equal to 0 for your x asymptote, and then just actually plug values to the left and the right of your x so for your domain, so that you can see how your graph falls out. And last but certainly not least is when we have a slanted asymptote, when your numerator is greater than your denominator. Notice the degree of my numerator is 2 and my denominator is 1. Then you will not have a horizontal asymptote, you will have a slanted asymptote. So to find that slanted asymptote, synthetic divide. So my root on the bottom would be -1. Bring down my 1. 1 times -1 is -1. 0 plus -1 is -1. -1 times -1 is 1. 1 plus 1 is 2. So I get x minus 1 plus 2 over x plus 1. And we simply ignore the remainder, and our asymptote becomes y equals x minus 1. So we can graph that asymptote. Crosses at -1, up 1 over 1, up 1 over 1, down 1, left 1. And we have this slanted asymptote. Again, we get our vertical asymptote by setting our denominator equal to 0, and that is where we get x equals -1. So it still divides it into 4 quadrants. They just happen to be slanted quadrants. So this is where it does not meet a parent function, so we are going to have to substitute actual values to the left of our x asymptote and to the right. So to the left of -1 could be -2 and -3. To the right of -1 could be 0, and 1 is actually on the asymptote, so maybe we want to pick 1.5. So -2 squared is 4, plus 1 is 5, divided by a -2 plus 1 is -1, is a -5. 2, -5. -3 squared is 9 plus 1 is 10, over -3 plus 1 is a -2. Again, we get -3, -5. So in this case, we may pick a point between -2 and -3, or since you know it has to hug the asymptotes, you can come through there as close as you can to it. Then when we put 0 in there, we get 1 over 1, which is 1, so 0, 1. And when we put 3/2 in there, that would be 9/4 plus 1, which is 4/4. That's 13/4. Divided by 3/2 plus 1, that's 2 2s, that's 5/2. So that's 13/4 times 2/5 is 13/10. So 1.5, 13/10 is almost 1. So we're about right there. So again, we can hug through. And we have our slanted asymptote. You should now have a complete picture of what's expected of you. Let's see if you can state the asymptotes listed here. Let's do our vertical asymptotes, our horizontal asymptotes. Here, our vertical asymptotes are at x equals -1 and at x equals +1. Here, our horizontal asymptote, y equals 1. Vertical asymptote and horizontal asymptotes on this one. Vertical asymptotes, we have none. Horizontal asymptote, we have 1 here at y equals 2. Vertical asymptotes here and horizontal asymptotes. Vertical asymptote at x equals -2. Horizontal asymptote, none, but we have a slanted asymptote. It looks like y equals mx plus b, y equals +2. My slope up 1 over 1, so that's 1x. So y equals x plus 2. And that is the kind of things you're going to have to do for your homework.